Hello, my name is Brandi Feldmann, and I will be presenting on PacketFence, the open source knack, what we've done in the last 2 years from DEF CON 19. This was originally presented by Olivier Brudeau, who is the PacketFence lead developer since 2009. PacketFence has been around since 2005. It is a fully supported, free, and open source network point solution, also known as NAC. Some markets that use PacketFence include banks, colleges and universities, engineering companies, hospitals and medical centers, hotels, manufacturing businesses, and school boards K through 12. Enforcement includes two deployment options, out-of-band deployment and inline deployment. Out-of-band deployment allows the solution to scale geographically and to become more resilient to failures. It can also be used to secure hundreds of switches and many of thousands of nodes connected to them. Inline deployment is supported for manageable wired or wireless equipment. It can coexist very well together with an out-of-band deployment. Authentication is done through 802.1x support, voice over IP support, and wireless integration. PacketFence supports an optimal registration mechanism similar to captive portal solutions. PacketFence remembers users who previously registered and will automatically give them access without another authentication. There are many advanced features that are now available with PacketFence. I am going to cover them all and elaborate on the descriptions more on the ones that people may not be aware of. Flexible VLAN management and role-based access control. It is built around the concept of network isolation through VLAN assignment. VLAN and roles can be assigned using per switch, which is used for default for VLAN, per client category, which is default for roles, per client, and using any arbitrary decision if you use their Perl extension points. Guest access, bring your own device. Portal profiles, which defines the registration workflow that will be used together with registration and remediation pages. More built-in violation types. PacketFence can combine DHCP, fingerprinting, user agent, and MAC addresses to effectively block network access from those unwanted devices. Automatic registration, expiration, and bandwidth accounting, which automatically tracks the amount of bandwidth devices consumed on the network. Some more advanced features include floating network device, which is a switch or access point that can be moved around your network and that is plugged into access points. Flexible authentication, routed networks, gradual deployment, and pass-through, which allows access to specified resources even when the node is in isolation. High availability, supported hardware, standards-based, and extensible, easily customizable. According to the presenter, there are 3 things that make up the secret sauce for PacketFence, which are: PacketFence is mostly Perl with some PHP, leveraging open source, and it is designed with high availability in mind. PacketFence was formed from 5 main key design decisions. These include out-of-band, which the infrastructure makes the decisions. Edge enforcement, which access is done as close as possible to the endpoint, which is the client's computer. No agent, because agents are error-prone and buggy. Web-based captive portal, and it needs to listen to everything going on around it. The captive portal provides various authentication mechanisms, redirection to the internet after authentication, and remediate information to users on installed devices. In order to reach the captive portal, DHCP needs to be provided, a DNS black hole needs to be there, and SSL redirection. The requested URL is redirected to the captive portal. There is an example on the screen, which it is www.google.com, is redirected to pf.inattech.com/captive-portal. Radius-based is the easiest network hardware support that they have, and SNMP is the most challenging network hardware support that they deal with. PacketFence Zen. Zen stands for Zero Effort NAC. Zen is a VMware virtual appliance. It is a pre-installed and pre-configured. Four advantages of open source are vendor independence, proprietary pricing is not questionable because some vendors charge per IP or per access point, which can get very expensive, and open source is not that way. It also has a familiar stack which helps users when they have questions regarding it, and security is necessarily not solely based on obscurity. The presenter mentioned different things that he has learned over his 2 years working with PacketFence, and the first thing is wired 802.1x bypass. 802.1x means port-based network access control. The process is as follows. You put a hub between the victim and the switch. This is done in order to prevent the port from going down. You wait for the victim to successfully authenticate. You then spoof your Mac with your victim's Mac. You then plug into the hub. There are two attack scenarios that I would like to cover. The first scenario is we keep the legitimate clients connected. The bad thing is there will be duplicated Macs on the same segment. The good thing is the original client could re-authenticate if the switch asks. The second scenario, we replace a legitimate client. The bad thing is we won't pass a re-authentication request. Good thing, there will be no network problems because there will be no duplicated Macs on the segment. Another thing that the presenter had learned and shared was the wired 802.1x on Mac OS X is buggy. After the 802.1x is re-authenticated and the VLAN is changed, the OS X does unicast DHCP requests to its previous DHCP server instead of Discover. It does 3 attempts with 1-minute delays between them. It then reports to a broadcasted DHCP Discover. A correct implementation does 3 unicast DHCP requests in a row. It waits 2 to 3 seconds for replies and then reports to a broadcasted DHCP Discover. Some other information includes this same issue happened on the wireless, but it was fixed in the 10.6.5 version. They filed a bug report and provided requested information, but they haven't heard back since. Also, they haven't looked at Lion at the time of this presentation was given by him. There are some bad things or disadvantages to PacketFence. These include, during the first installation step, SE Linux has to be disabled. The release cycles are too short for a core infrastructure piece of software. There is no Nmap integration, and external code contributors are scarce. He also mentioned some good things that he has seen and that has happened during his time as the lead developer in PacketFence, and there are several good things about it, and I will cover 2 of them. The first one is usability. Usability has changed a lot from when it first started and even now. It has been reorganized and the documentation has been simplified. Also, the installation has been simplified, and the upgrades as well. The default VLAN management technique covers a lot of use cases. The second good thing or advantage to PacketFence is enterprise. There are web administration user rights. There is out-of-the-box support for routed environments. There is 64-bit support, and there is fancy guest workflow support. The presenter also mentioned some short-term and long-term goals that they had in mind at the time that the presentation was given. So some of these may not be relevant anymore. But the short-term goals include inline mode to ease support of legacy network hardware, which was in the 3.0 beta. They want to implement radius accounting and bandwidth monitoring. They would also like to implement NAP and statement of health client-side checks. They want VPN support and Debian and Ubuntu support. The long-term goals are active clustering support, Nmap and OpenVAS integration, and making this stuff the click next 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 easy to install for users. They would also like to rewrite the web administration interface. The presenter mentioned at the end of his presentation some research topics regarding his presentation and PacketFence. These topics include if map support, open source multi-platform client-side agent, and Trusted Computing Group's Trusted Network Connect, TNC. If you are interested, he encourages you to look up this information. This is my sources slide. The original video is found at the link below. And then I also listed the other sources I used for the information that was in the PowerPoint. Thank you.